Well, hi, and welcome to my shop, and thanks for coming and keeping me company here for another day of experimenting with this particular radio. Yesterday I did some sort of general experiments with it, kind of to find out what I'm able to do in my shop here with the equipment I have, and I was pretty happy with the result. And so today I want to go another step further with that experimenting, and this is all around the mixer tube and what goes in and what goes out and things like that. And I think what I want to try to set up here is a controlled circumstance where the receiver is receiving two signals and then is processing them the way it normally does. Processing being a strong word for a radio like this. And just looking around inside with the SDR and seeing what's really going on with the mixing of these different signals and the like. That's what I hope to do. Okay. First thing I'm going to do is turn this down. I'm going to attach the SDR antenna to the antenna inputs of the radio. We're going to look at what is on the antenna terminals right now. And what do you expect to be there? Noise. I mean, there's enough wiring here to pick up something, and not to ignore the leads from the SDR, which can also act as an antenna here as soon as I figure out where I am connected. Okay, so if you want to do the SDR thing, take that apart. I don't think I even want this in here. Okay, so both radios basically listening to the same spot, or the same stuff, these wires and connectors and the like. Let's turn this up a little bit. And put the sound on the SDR here. A little hard to tell them apart. They're just noise. They should be the same noise, shouldn't they? Shouldn't they be exactly the same thing once I have these connected? Okay, so if everything is working the way I would hope, let me turn the sound off here too. Then what we have on the display right now is the kind of stuff that's reaching the antenna terminals of this radio or are ready to go into the radio and go through it. If any of those signals you see are converted or are at 455 kilohertz. So we look right in the 455 kilohertz area. I'll put the red line there so we can see it better. There we are. So anything right there, as detected on the SDR at the antenna, is going to go through the radio. There's nothing there but some basic noise. There's no signal right there. Good. The big signal over to the right is the local oscillator on this radio. You see how powerful it is. And this is being picked up at the antenna terminals by the SDR, so there's a good chance this is coming out of the back of the radio. If you were to put a long wire antenna on here, as I've done, then that antenna is probably going to radiate this signal, I think. Okay, now what if we introduce two more signals? So I'm looking for an area that's fairly quiet in there, right around 800 kilohertz. The signals look pretty quiet. I don't want other signals. I'm looking for a nice quiet spot to do this experiment. So if we did 800 and 850, something like that, let's tune this radio to 800 and see what happens. It happens just about exactly where it is. So see, now there is a traveling signal there, right around the 800 mark, right there. Now what are we looking at on the SDR? We're looking at the antenna. You're not looking at the output from the detector. Well, maybe we are. Maybe some of the output of the detector is making it to the antenna or to my SDR input. Anyway, what are all those signals moving around down there? Artifacts of the detector. If I were to knock out the local oscillator, those artifacts should disappear. Okay, we'll do that. So what I'm doing here is I'm shorting out the oscillator. Now when I tune the radio, I can see, look at the waterfall display, you can see a bunch of signals disappearing. Okay, now turn it up a little bit. Things got pretty quiet. All we should be hearing is any 455 signals at the antenna. I can make it all the way through the radio, and there's nothing there. Excellent. This is kind of what I want. Look up around 800. Looks about the same. Oh, my finger. Tune the radio here. And what happened to my focus? Focus, focus. There's no focus. Notice there's nothing moving on there at all now. Even though if the local oscillator were operating, I'd be moving it up and down, and these other signals would be traveling up and down. I think they're all artifacts of the, yeah, there's absolutely nothing happening. This is an interesting state right here. Getting rid of the rest of those interference signals, it strikes me that if I manage to suppress them enough, I'm going to suppress all the interesting signals I'm going to try to generate here. Okay. Now I am going to want to think hard about this. So we're going to put in a couple of fixed signals right around 800, and then we want to see what comes out of the radio. And we really want to see what comes out of the detector. That's really what I want to see. So that means hooking up the SDR to the, yeah, we don't need it on the antenna anymore. We need it back on the detector. Okay, there we go. I think I'm going to switch the radio off. Give it a moment. Just worried there's a little bit of a charge. I'm going to stick on my SDR and pop it. I don't want to pop it. Okay, I know from yesterday that this kind of works. Here we go again. See if it looks any different now. Just now I have a lot of wire kind of hooked up to the detector output, but the detector output's pretty strong, I think. I've got it padded down fairly seriously. I left out some of the padding here. I left out a times 10. Seems to me it wasn't all that strong yesterday. And we... Did I do the right thing here? SDR? Yep. Radio's on. No oscillator. We'll tune it a little bit and see if we see anything happen. Oh yeah, there's something happening. Alright. It's kind of an interesting thing right here. This is interesting in itself. So we're tuned to 900. So if you find your way to 900, and watch right around 900 as I just tune back and forth a little bit. Now, do you see that signal disappear there? Now the radio's tuned closer to 800. See the signals around 800 are being peaked up, and down, down, down we go. Can't see my hand. We'll go up again. So this is the front end effect. This is the front end tuning. It really looks like you'd have to say boosting. I hate to use the term, but boosting signals. Yeah, we might as well use that term. Boosting signals as they tune along. So how accurate is that? So I would say I've got this boosting right at the top of the band there, 1600, and it's tuned to, well, 1600. me this isn't a very precise way of doing it, but you can kind of see the actual front end response curve if I just zip it back and forth. If I put in more noise, it will come out looking, in fact, if I put in a sweep, you'd be able to see it too. But this is pretty effective right here. So do we want the radio tuned around 800? Well, if it's tuned around 800 for this test, we're going to have all these guys to deal with. So I can tune it way up here. Now, does that mean I've got control over the signal levels coming into the back of the radio, so I can just jack them up till they're high enough coming out of the signal generators. Without the local oscillator operating, I want to bring two external signals from the antenna very close together in frequency and see if the detector produces another signal, if they get mixed. That's my experiment to start with. Okay, so who's hooked up to the antenna? Right now, nobody. Okay, so we're gonna. Okay, so here goes one signal generator. That's running at around 1,000,000 hertz. So let me vary the frequency a little bit. See if it's sitting there. Yes, it is. It's sitting there already. So we're gonna take it down to the area we're interested in, around 800. That's distinctly stronger than any noises around there. Okay, signal number 2. I'll take the other signal generator and I'm just going to parallel it in here with the first one. And maybe reasons for not doing that exact thing. Again, I wasn't watching, but it looks like it knocked down the signal strength from here. This guy is putting out, the other signal generator is putting out a pretty strong signal. Should be able to see it. Okay, I'll vary it a bit. There it is. So I'll bring this one down near the other one. It's going to listen on the radio. If the two signals are 455 apart and they're mixing, we should hear that. So first one's at 850, second one's at 950. So we're going to bring the second one down and maybe we're going to hear something here. Oh, I hit the end of the road. I can't go below. I'm right on the band edge here. 800's down here. 800. Okay, gotta go. Oh, well, that was it. Now that went right through the IF. Through the IF from the antenna. And did you hear there's a heterotone? Heterotone. Yeah, heterotone. New word for today. A heterodyne. Let's get it back. Now, why that tone? Oh, you know what that is? That's the modulation tone. There's another one. Okay, just calibrating my gizmo here. What's that whistle? Let me vary this frequency here. What's that all about? Okay, I'm going to vary the frequency of the other signal. Nope, not related to this. So there has to be a 455 signal reaching the detector, and there has to be modulation in it to hear this. The signal we're sending over there is pretty much 455. Not sure what to say about that. Sounds like the same thing the BFO does. Same fact. Okay, we'll leave that one aside. Focus on what we're really trying to do here. Okay, so now, watching the SDR, getting straight which signal is which. Okay, so we can see this one. I'm going to put it what I think is 850. I didn't hear anything coming out. Okay, there's 850. So if we put the other signal generator 455 away, which would be 800, we should hear it, if they mix. Okay, so I don't hear any mixing. So I give it a little more power here. Ooh, it's a lot more power. How about some more volume? Okay, more power here. 2 strong signals now. Nothing. Nothing at all. I would say there's no mixing of these 2 signals. And I think that's what you would want. You don't want the signals on the antenna mixing. And the way the mixing is done in these tubes, a couple ways, but one way to think of it anyway is the local oscillator is causing a signal in the detector tube electron flow, and with the electron flow pulsing with the local oscillator, when the antenna signals come in, they end up in this pulsed flow and they end up mixed with it. You see how that works? Look at that. That's how that works. So it's not just putting 2 signals together. Unless you put them together in a non-linear device. That's my understanding of this. Have we not overloaded this thing enough yet? If we overload the first tube, drive it into some kind of non-linear operation, will we start getting mixing? I got no idea. Let's find out here. Okay, we're going to crank this up. Oh, look at the other signals that just appeared. I think that's a sign of an overload happening. Let me get right up at the top here. Okay, now I'm going to move this other signal generator. Do we see anything else moving? Actually, well, there's some stuff moving way up close to the... So on the right side of the SDR display is another loud signal or strong signal, and it's a harmonic of this signal generator, I believe. So if I change the frequency here, I see it change there. Oh, wait a minute. That was kind of nice. They're picking stuff up. This is a hard signal generator to steer. So if you look where the red line is on the SDR, that red line marks where signals are at the IF frequency. And if you can get one there, you hear it. So this powerful signal is mixing with something. It's not mixing with this other signal generator. Oh! It is. What do we got going here? So this one I'm changing. It's around 800. And the other one is around 650. It doesn't make 455, does it? This is exactly why I'm doing this experiment, to find out what goes on. Not necessarily to understand what goes on, that would come a little later. Okay, let's try this. Get this back. And what if I reduce that first signal down to, let's call it, a more normal range, whatever that means. Now what? Volume up. So I think this is a demonstration of just what I was saying. If you drive the tube into non-linear operation, then it will start providing it will start generating harmonics and do mixing. It will generate harmonics and do mixing. Can we see the harmonic? Okay, so looking again at this signal and looking up for its harmonic is do. So pretty weird. On the right hand side of the SDR screen is a signal moving in the opposite direction to the main signal, the one I'm varying. And I'm pretty sure that's an artifact of this mixing deal that's going on. Is that because this other signal's there? Oh, there's an awful lot going on here. I'm going to move the SDR display so it's a little more over to the side here. I still want the 455 on there. Okay, so 455, I'll put the red line there again, just so we know where it is. Okay, identifying signals again. So, okay, so that's that signal generator. And you can see some odd signals happening here and there on the right hand side. So one of those could be a harmonic. So I'm around, let me set this to 600. Okay, so we're at 600. So harmonic would be at 1200. There's nothing, there's something there. Is that it? No, nothing at 1200 is not moving. Instead, we've got something moving. It's hard to spot. Up around 1700. How do you get there from 600? You get to 1800. Okay, just making observations here. Lots of stuff to think about after doing this. Our other signal generator is not on deck right now because his output is down. There he is. Okay, so what we've discovered so far is, looks like putting two normal level signals into the detector on the regular grid, local oscillator not in the picture, no mixing occurs. It looks like if you were to make one of those signals large enough that it's no longer operating in the linear portion of the tube characteristic curve, you can start getting mixing effects taking place. The mixing effects can only be seen, that's not quite true. I was going to say all the SDR can see right now is 455 kilohertz band, but that's not true. It's seeing everything we're seeing. It's seeing all that stuff. But it does see the 455 converted signals. Okay, I'm going to bring in the local oscillator again. So first we're going to set these two frequencies to around the 800. One of them's already there. I'll set the other one around 800. Not on top of each other. Okay, so this would imitate two local radio stations, one at about 810 and one at about 850. Now I'm going to start up the local oscillator here. I'm going to turn down the volume because I think things are going to get louder. Yes, they do. Oh, what a change of picture. So I think the first thing and this is, I'm not sure if I'm correct in this, the local oscillator is designed to operate in the non-linear portion of the tube. The signal will be so strong that it's driving the tube literally into cutoff, or at least in non-linear operation. And that's why the tube will mix this signal, the local oscillator signal, it's a whopper of a signal, with the received frequencies. Now, the two frequencies I've set up there, they've just become the same as the other noise signals in terms of level. Let me just put the, I just flipped on the modulation briefly to make sure we're not hearing it. Okay, so I'm going to tune the radio down in the range of all the stuff in the just below. Where did all that come from? Just below around 400, around on the left side of the display. Where did all that stuff come from? That wasn't there before, was it? Let me put the short back on. Ooh. It's there. It's just much, much weaker. Well, it looks like a different set of frequencies. This is interesting in itself. Okay, I'm going to take it off again. There's a huge pile of stuff around 400. Why? Okay, I'll tune the radio a little bit and we'll just watch everything. Watch everything. Everything's moving. Everything's moving, but the two signals I'm feeding in and this thing at 1100. So remember, each time something crosses the red line on the SDR, you hear it come out of the speaker. Right? The things we're seeing in the around 455 have to be signals that exist 455 kilohertz away from the local oscillator that I'm moving. So we can figure out what those are. Except the local oscillator seems to wipe them off the screen here. Let's just keep going here. Now, the two signals right here. These two signals. These two signals are these two signals. And here's some interesting stuff. Okay, so I'm going to vary one of the signal generator frequencies. Look at that. Why that? Wow, this is more interesting than I ever imagined. This is way more interesting. This is going to take a couple of days to analyze this kind of stuff. So if we think about it here for a minute, let's just take one of these signals. Let's take this one. It's some distance away from the local oscillator. The local oscillator is in mixing mode because it's, according to what I'm thinking, it's operating in the non-linear portion of the tube. So it's mixing itself up with these other signals for that reason, which I cannot explain in more detail. So the distance from here to here, this is 875 and 1400 is about 525, I think. .525. So 525. So we should see a signal at 525. Look at that guy right there. 525. So that's the mixed result of this guy and this guy. Then obviously this one must be this one. I mean, if you look at them, they obviously are mirrors. Even this is mirrored here. What are these two guys up here? Okay, that's interesting. What are those other two guys I just pointed at? So I'm going to move the signal generator frequency a bit. More products. That's the word for it. More products. So we're getting the addition. We're getting this signal 1400 plus this signal. I'm sure it'd be easier if it was at 900, wouldn't it? Let's put it at 900. Make the math easy here. 900. Make the arithmetic easy. Have I ever mentioned my father was a high school math teacher? Was zero interest in math or teaching. Yeah, true. Okay, so I got this at 900, this at 1400. That's easy calculations. That's 500 between. So if we add 500, we get 1900. We got 1900. There it is. This other signal's farther away. This is farther away. Now this explains why there's signals traveling in all directions when I'm fooling around with this stuff. No, they're all going in the same direction. They're all going in the same direction. Oh, there's one going the wrong way. There are. I'm tuning it too fast. Let me turn it slower. So I'm turning the frequency up. You can see right around 900, there's something going down. What would that be? Okay, so let's analyze that one. So I'm going to stop here. No, I want to stop on 1400. I could stop on any whole number. Oh, it just changed direction? No, it just popped up. Hey, what happened to the local oscillator? It kind of died there for a moment. So some dirt in the capacitor or something. Okay, back to what we're doing. So we're positioning it here. Where'd that little guy going the wrong way go? Where'd the guy going the wrong way go? There he is. Okay, we can't get this right. Well, I'll get it in the middle here at 1350. How about this? I go a little bit higher. That won't help. 1350 is the best math I can do. So we got 1350 oscillator signal. We got a 900. Let me turn the other one out of here. The other signal generator. Just reduce it. We got 900, 1350 mixing. Now the frequency of the thing that's going the wrong way. Where is it? Where is it? Okay, it's a fairly strong signal. It's 950. How do you get 950 from 900 and 1350? Is that signal really due to the other signal generator? Let me vary the other signal generator a little bit. No, it's not. Or is it? Wow, this is pretty hard to figure out. The thing pops up from nowhere. What is the deal with that? Pops up from nowhere, but doesn't vary. Doesn't vary. Is it an artifact of the SDR itself? It's possible. That local oscillator is not only overloading the detector tube, it's overloading my SDR. The SDR is a cheap SDR. It behaves poorly, easily overloaded, and then there's all kinds of weirdness that comes out of it. Okay, so what have we figured out so far? Two signals on the antenna, they are not going to mix. If I could reduce the local oscillator down enough, we'd probably find out it's not mixing either. Maybe that's not true though, because I've read too many conflicting descriptions of how the actual mixing of the signals takes place. And I was taught this in college. I certainly can't remember what I was taught about it. It would have been taught in a very mathematical way, which I have a little bit of trouble absorbing sometimes. What's next here? Really, just to figure out what all those other signals are. Well, let's just get more information here. We'll just fool around some more. So if I bring the local oscillator down, maybe there's some more. Maybe something more dramatic I need to pay attention, like that thing coming in from the right. Now that's probably double the local oscillator. I put the local oscillator on 1,000,000. Yeah, so there's another local oscillator coming, another signal coming, the harmonic of the local oscillator. Now, if there happens to be a noise signal way up close to that, it's going to come out of the radio, isn't it? I don't know, let's find out. Okay, so I'm going to steer one signal generator up that way. Where are you, man? We're at 900. So what's happening is we're just underneath the that huge local oscillator thing. I'm on full tilt here. That's about all we got to give it. And what were they doing? Oh yes, moving the frequency up. We'll probably see it when it gets up around somewhere. Up around, we're at 9. I'm at the end of the run here. 9. Here we go. I gotta change this again. Coming down from 3. 2. So we're crossing 2 now. 18. Still don't see it. Why don't we see it? 15. Okay, so let me put on the tone here. Turn up the radio a little more. So I can hear that change I'm making. 400 hertz, 1000 hertz. Very faint. Very faint. A little more power. So at this point, if we look at the 455 again, down here, again, for us to hear anything, it must be coming through the IF at 455. So there must be a signal arriving where the red line is. So I'm going to vary this guy and watch. It gives me the impression the IF is not tuned quite right. It's at 455. Okay, I'm going to listen to the signal using the SDR briefly here. What is the SDR here? It hears exactly what the radio is hearing, but the radio hears it best not at 455. I would say there. And the actual frequency we're listening to is 450. Wow, what to make of that? Now, so the second local oscillator, a local oscillator harmonic, has the capability to act as the local oscillator, convert signals, and have them come out of the radio. But you would think it'd be greatly suppressed. Now the radio's tuned to the low end of the band. Let me tune it to the high end. Oh, well, of course, I'm moving the local oscillator when I do that. Right? Something came through pretty good. You can see all the signals arriving at the IF. Something going backwards. Something going backwards in the IF. Big, tall signal going backwards in the IF. Why are you doing that? So I've left the signal generator up at 1500. Is it this? Yes, it is. $1,500. Well, you know what's happening? It's being converted by the other, by the real local oscillator. Is that true? So 1100 in the real local oscillator. Yeah, 15. Yeah, it's 1450, 55 exactly. 1450. So you can have a station running at, say, 1500, a real, like a local strong radio station at 1500, and when you tune the radio low, the harmonic of the local oscillator can mix with it, and you'll hear it come out of the speaker, even though your radio dial says 800. Now it'd have to be a pretty strong signal because we have that front end tuning that's also suppressing everything but the target frequency. It's just if it's really local to you, if the transmitter was really local to you. In fact, when you go down in frequency, that's the end of the road. So that's as low as a local oscillator will go. So at that point, yeah, it's converting 455 below that, the end of the band. You know, maybe that's enough for today because the sun is shining, and just really showed me a little more than I expected. Although I think the one thing I got to grip on is you're not mixing. You see, a normal radio only plays stuff at 455 kilohertz. So there could be a world of stuff going on outside of 455 kilohertz in these radios. You never hear it. You never know it's there. Even people working on these radios, doing all that stuff, never going to know it's there because the radio's only sensitive to the 455 opening, if you like. But using the SDR, we can see all kinds of stuff that's going on. All kinds of stuff is going on. Okay, well, thanks a lot for watching. I'm not sure I really concluded anything here. Just lots of stuff to think about. And, you know, if you've got an SDR and you've got a few things, you can be doing all this stuff too. I'm not using much equipment here. I'm using 2 signal generators, but there's room to fool.